now your idea is we are applying force F1. Because of that I am getting sigma x stress. Then I am applying force F2, because not F1, sorry, not F1 F2, Fx. Because of that I am getting sigma x. Then I am applying Fy force. Because of that I am getting sigma y stress. And then I am applying Fz force. Because of that I am getting sigma z stress. And because of Fx I was getting three types of strain: epsilon x, epsilon y, and epsilon z. Because of Fy also I was getting three types of strains: epsilon x, epsilon y, and epsilon z. Because of this also I was getting three types of strains: epsilon x, epsilon y, epsilon z strains. And you can see all the formulas are different, right? Epsilon x, epsilon x, epsilon x. You see, here it is minus mu by sigma y by E. Here it is epsilon x by E. And here it is minus mu by epsilon z by E. So if all the forces are acting at a time on the bar, what will happen? Then all the strains you have to collect together in x direction. So you will write resultant strain in x direction, so that you can write as epsilon x. That is going to be, of course, because of what is the main force acting in x direction? Fx is acting in x direction. So because of that this stress will come into picture. So sigma x by E, and remaining two you have to copy from that: minus mu times of sigma y by E, then minus mu times of sigma z by E. See how easy it is. People are in fear in 3D. What is 3D? How easy it is. Okay, then in same way we can go for the next heading: resultant stress in y direction. Again epsilon y is equal to epsilon y divided by, okay, see, you can write in this way also. Like first, because I took x direction, so I took x here, so I am taking y direction.